Good morning. Here we're going to start the discussion of IViewOps as set up for a specific plant. We are using the KNSG plant as an example, but this could be any other plant, and in the course of the videos we refer to other plants that are using IViewOps. Now the first thing first, IViewOps, after it has been set up for your plant, is simple to use. That is the philosophy around how IViewOps should be installed. It should be simple to use for the operator, that does not consume any more than a few minutes of the operator's time to view the results. Now there are small plants, less than 2 mgd, 8,000 meter cube per day, that are using it. There are mid-sized plants and larger plants also using it. So for each plant, we create one video, which is the introduction video, which shows the layout. After one has reviewed the introduction video, one should look at the 4 videos that describe the setup. Now, not all of the 4 videos may apply to each plant, but here is how they are structured. The videos are 10 to 20 minutes each. The first one uses what we call the default Excel file and the IViewOps files, which are the IVO and IVO1 files. Now these are custom files for the plant, because each plant is different from another plant. So when one sets it up, it becomes customized to the plant. Now in the second video, we discuss how you view and modify the dashboard, which you should not have to do every day. You just do it once, or the operator does it once, and you stay with it, and you keep the dashboard running every day, and you view the results as it shows up on a daily basis. The third is to use it for an operations planning, or a process planning, or an asset management planning, or engineering, and you use the file that we are using in the plant to leapfrog from that and get to much better analysis than you could have got otherwise. And the fourth is for more sophisticated applications, probably at all size plants, but definitely medium and larger plants, where you're using the monthly operations report or SCADA, the database in SCADA, to transfer data to IViewOps every day in an auto mode. So it shows you the data communications features. Now, as I mentioned, we have a philosophy. We need to be able to accommodate all sorts of plants where the operator may have multiple tasks. When we look at small plants, we are finding that the operator has to work on different things, like may have to work in the lab, may have to go collect samples, may have to work on a pump, may have to go to a pump station. So there are a variety of things the operator has to do. So the operator cannot be expected to sit in front of the computer, manipulate variables. Instead, what we try to do, or what we are doing at the plants, is for the operator, we put IViewOps in an auto mode. The auto mode requires minimal effort. The data comes in automatically into IViewOps. It runs automatically. It shows the trends over the last 24 hours. And what we ask the operator to do is keep the dashboard for the current dynamic state open. So when the dashboard for the current dynamic state is open, the operator can look at the results at different locations around the plant, see what happened over the last 24 hours, and use that as a guide to make decisions. Now, in addition to this, there are parallel scenarios which we start discussing in video 3, which can be used for performing operations planning analysis, for performing engineering analysis, maintenance analysis, and asset management analysis. And the engineering analysis may be for retrofit upgrades. the maintenance and other asset management analysis may be for timing and funding replacements. So now let's get to what is in this first video. We start talking about the default Excel file, and we'll show you the simplest method of setting it up and using it for a small plant. We talk about the 30-day average sheet, which will bring in the 30-day average of a few critical pieces of data to set up the steady state and run it every day. We talk about the data for the last 24 hours. We will introduce but not cover the alternate sheet, which is used for operations planning. That's covered in video 3. We will introduce but not talk about the monthly operating report or SCADA, which is covered in video 4. We do cover how you set up the IViewOps in video 1, but in the intro video. But in this one, we'll talk about how to set it up in manual and auto modes. So we now have a two-part video for you. First would be how you use it in a manual mode. The second will be how you use it in an auto mode. So let's look at this plant. This video is being recorded on February 16th, but you will find that when you save this file, it registers a date of February 15th. That means yesterday's date. It's looking at the last 24 hours. Now it can be midnight to midnight or sometime in the day to sometime today. Now what is the data that a small plant needs on a 30-day average? So this is the current 30-day average. What is the minimum data that is required? Now in this configuration, which is for this KNSG plant, the only data on a 30-day average that is really critical that one needs to look at the last 30 days and provide is this WAS flow rate. The rest, the final effluent flow, it does not change that much on a 30-day basis. The RAS in this plant, they're not changing it that much on a 30-day basis. And they have aerobic digesters. How much of the WAS is supernated out of the digester? Well, this one is set at 60% of the WAS flow, which is typical for them. Again, this does not change that much. So the only piece of data we are asking be entered is this 30-day average of WAS flow. And the next part will show how to make that simple, how to get that from the monthly operating report. So now let's look at the second sheet. What are we asking here? Again, if you just follow these arrows, we're asking in the last 24 hours, what was the final effluent flow? You may have it in the monthly operating report or you may have it in SCADA. So you do need this piece of information. The next critical one is what is the mixed liquor temperature? Now you can look at the monthly report and get it from there, or if that's proving to be difficult because you do not have the lab data as yet to feed into that report, or you do not have a sensor in the aeration basin which is giving you the mixed liquor temperature, then you can also use this as a guidance in this plant. What we have done is looked at the 2013 data, and here are the different temperatures in Celsius for the mixed liquor at different months. So based on the month, this is February. You can say, okay, February I'll go and enter 11 Celsius. The actual temperature may be 10, 10.5 Celsius. And there are ways to get that, but if you want to keep things simple, here is that. Now you have a set of optional data. Like if you're operating all your nitrate recycle pumps in this plant in 2 basins, your flow is typically 8 mgd. Your alpha 208, which you're using for chemical phosphorus removal, you enter your dose that you have been using over the last 24 hours. As an operator, you probably already know the dose, and as a small plant operator, you probably already know how many nitrate recycle pumps you're running. As far as the DO at different locations in Oxic A, B, and C, well, we ask that you just work with this and enter the value in Oxic B. But if if you want to keep life simple, just leave it at the default value. For this plant, it does not change that much, so just leave it at the default value. Same thing with the digesters. Okay, which basins are in service? You can toggle and set it up this way. In a more sophisticated setup, we can connect that directly to SCADA, and SCADA tells IVops which basins are in service and which are not in service. Now there is an interesting part to this plant. Every plant has something interesting and something to learn. This plant is shutting its operating blower for the aeration basin on and off, shutting it off and turning it back on at a certain time of the day. It does this because it does not have enough blower turned down at this current flow. So here is where you start getting into dynamic simulation and how you have variables feeding in from Excel into dynamic simulation. You see a timeline here. Over the 24-hour period, you will go see that at 9 a.m. out here, the blower has been shut down, and at 11 a.m. out here, the blower has been turned back on. That is your typical pattern. And you do not have to go back and adjust this every day because you're operating on the same pattern every day. So you just leave this alone. But if you do make a change, you make the change over here. Now again, in a more sophisticated setup, this data would come directly from SCADA. SCADA would feed to an Excel file which feeds into IVops. Now, we do not cover the sheet alt here, which is used for operations planning, but I just want to make you aware of this, and we will cover this in video number 3. So we have covered the 30-day average, we have covered the last 24 hours. Now, what do we do with IVops? Well, I mentioned that the first part we talk about how to run it in manual mode. Well, this right now, if you look at each scenario and you look at the mode, you have a choice, running it in manual and auto. So the first two scenarios, which is the current steady state and the current dynamic simulation, which are looking at your last 24 hours, you have to make a decision whether to run this on manual or auto mode. Let's go on with the theme of running it in manual mode. If you are in manual mode, what you will do is you will manually import the data. Now, so we are not going to set it in auto mode. We are going to manually import the data. So if you press the start button here, we've gone to import. Okay, let me back up a moment. You go to import and you press the start button, and it'll start importing the data from the sheet to which it is linked. So which sheet is it linked to? Well, you have to do this only once. IVops is set up for your plant. So we do this once we set it up for the plant. We go here and we set up the path to the file to which IVops is attached. And this is covered in the user manual or in a separate training video. So again, let's go back. We went through attach. Now go to import, press the start button, and it will start importing the data. Now once it finishes the import, it'll say if there are any errors. If there are errors, we need to eliminate that, but you should not have any errors because your file is set up, so it says 0 error. So the data has been imported for this file, and essentially what you will find is that, for example, if you look at the liquid temperature here, it says 11 Celsius. Well, this data came in. The source of this data was out here. This 11 Celsius got fed into IVops. Let's look at the clarifier. Let's look at the SVI. And here's the SVI of 90. You can see this is the link up, and the SVI is 90. If you go back here, you'll find that we have fed in these values from here. So let's make a small change and see how this takes place. Let's say the SVI instead of 90 is going to be 80. Okay, so I've changed this to 80. Go here, use the save button, save it. So this saves the file for IVops to go read. Now we go back into IVops, go into import and press start and let it finish the import. So once again it has finished the import. We're going to go look at the SVI, and now you see the SVI is 80. So you have got the updated data here. So then if you want to run it with an SVI of 80, you'll press the run button. What I'm going to do is I'm going to switch it back to 90 just to save time on the run, and I'm going to re-import it to set it back to a 90. Press save again here. So anytime you make changes here, remember you need to save it, otherwise the changes exist only on your screen. You need to save the Excel file and then do the import. So I'll do the import again. You see the SVI is back at 90. I've done the import again. So the next step is, if you're on manual mode, you press the run button. You're on the first scenario. We'll press the run button, which runs the current steady state. So I press the run button and you say start, and it'll go through and finish the computations. Now in another video we'll talk about how you look at the results. There are two places to look at the results, or three places actually. You can look at it in the dashboard, you can look at it in the results tab, or you can look at it in the flow stream. So to go look at the dashboard, you'll single click on the dashboard and it'll open it up and you will view the results over there. So here is the dashboard for the steady state. I have just clicked on the dashboard, single click, and it opened it up. Again, we cover a lot of this in video number 2. I will now close the dashboard here. So I don't want to save any of the changes I made to the dashboard. I just go to this X, not this X here, but the X on the line with the dashboard where it says dashboard. Close this and it'll say, do you want to save the dashboard? I'll say no, and I'm out of the dashboard. You can look at the results in the results tab by clicking on it. And you see the hierarchy here. Go to a flow stream. Let's say we want to look at the secondary effluent. Go to the secondary effluent and it'll give you the results in steady state for each of the different scenarios. You can look at it in the table. You can look at it in the graph. So let me close the results. And the third place you can look at it, for example, if you want this coming out of the filter, you click on the pipe. It'll give you a summary of the results here. It'll give you more values of the various parameters over here. And then if you want to go into additional detail, you'll be able to see things like how much AOB, how much NOB, etc. you have down here. So let's look at the feed to the clarifier. I click on the pipe that is feeding into the clarifier, how much ordinary heterotrophs, how much ammonia oxidizers, nitrite oxidizers. If you had phosphorus removal, biological excess phosphorus removal, we'll have PAOs. If you had anaerobic digesters, you'll have the methanogens, and all those are here. Again, you don't need to know all that if you're just looking at it for day-to-day operations. What you're interested in is the TSS, VSS, going into the clarifier, ammonia, etc., nitrate over here. Now, let's look at the current dynamic simulation. You go here, you've already imported the values. If you press run, it'll run through the current dynamic simulation and go through all the time steps over the last 24 hours. So here I press run, I press start, and it'll start going through the computation. What I want to do in the second part of this video is just briefly show you how to set up IVops in an auto mode. What we may do subsequently is set this up in a separate video, like a video 1B. So your IVops, if you're going to run it every day in the plant, you should go here and switch the mode to auto. When you switch the mode to auto, it tells you when it's going to run next. It's saying that in 6 hours it'll run the next time. Well, how do we know it's going to run in 6 hours? Well, when we had set up auto, we defined the time that it was going to run the next time in auto. Here it's saying at 1:15 p.m., which is 13:15, and it's also going to auto save. So I went to the options, general, and here is where I had set it up. Now, as an operator, you should not be switching this around every day. We'll make a decision based on when you enter data into your MOR, and or when the SCADA system is set up to create these Excel files. And then we just define the time here once, and it'll go run it in auto mode. Now, there is one other piece of information that needs to be set up, which is set up the import to also be on auto. You see over here, it's saying import the values at 1 p.m., which is 13. Set this up on auto, and when you set this up on auto, you'll see another line here. It says the next import will take place in 5 hours 51 minutes, which is essentially looking at this clock over here and saying, well, when is it 1 p.m.? So that's how your file is set up on auto import and auto. You need to go into the import, set it up on auto. You need to go into mode and keep that on auto. Now, the other thing which we advise is that you should keep your dashboard open, at least the dashboard that you need to view. Now, one thing you need to realize is that each scenario has its own auto schedule. So you need to go into current dynamic state, and you need to set this guy up also for auto. So this one is also running on auto right now. You do not need to go into evaluate steady state and evaluate dynamic simulation, because these are more for operations planning or maintenance or engineering analysis or process engineering analysis. So these would be on an as needed basis. So keep those two on manual, but keep the first two scenarios on auto. Now, the last thing I keep harping on is keep your dashboard open so that you can view the results in the dashboard. So that's something we will talk about in the next video, which is viewing the operations dashboards for the current steady state and the current dynamic simulation, which are the first two scenarios. So the one last thing is, once your dashboard is open, let's say for current dynamic simulation, you'll be able to see the tables and graphs of the flow weighted average over the last 24 hours or the trend over the last 24 hours at different locations along the plant based on what you have set up or what has been set up for you. We now move on to video number 2, which is how do you customize your dashboard, and it should take you no more than 15 minutes to learn how to do that. It's a pretty simple set of procedures.